So we've been talking about ciphers, and we talked about two types of ciphers, the shift cipher and the affine cipher. And remember, we talked also about the Caesar cipher, which was a special case of a shift cipher when the K value is 3. So these ciphers that we've looked at, and there are several others, but the ones we've looked at, the shift and the affine cipher, they're basically what you call character replacement ciphers. Character replacement ciphers. These are character replacement ciphers. These are ciphers where one character is replaced with another. Characters are replaced with others. Cipher where one character is replaced with another. So these two. Another type of cipher is called a block cipher. A block cipher, and that's kind of where you scramble your characters. You just move them around. So a block cipher. Block cipher. Ciphers where blocks of characters are transposed. In particular, we want to look at a transposition cipher. It's a type of block cipher, transposition cipher. So, and we're going to describe it in the following way. Suppose you have a message with k times m characters, km characters. So consider the permutation sigma 1 equals A1, sigma 2 equals A2, and so on and so forth. Sigma m equals AM, where the a sub i's, A1, A2, and so on through AM, they're elements of the set 1, 2, 3, and so on through m. And what this is saying, that sigma 1 gets sent to some number between 1 and m. Sigma 2 gets sent to another number between 1 and m. Sigma 3 gets sent to a number between 1 and m, all the way through sigma m gets sent to a number between 1 and m. So to encrypt a message, we split up the text into k blocks of m. Of length m. We send the ith character in the message to the ith position. So we're going to move characters around to different positions based on our permutation. So let's do some examples to see how this works. This is actually quite simple. Here's an exercise. Let me see. Encrypt the message flee at once. Flee at once. 1, 2, 3, 4, 5, 6. Flee at once. Now, with a certain permutation, with the transposition cipher, permutation, sigma of 1 equals 3, sigma of 2 equals 1, sigma of 3 equals 4, and sigma of 4 equals 2. Now let me actually show you what's happening with this permutation. So the idea is you have a permutation is a function. You have a domain, those are the inputs, and a range. So the inputs are 1, 2, 3, and 4. Your function is called sigma, and your range consists also of 1, 2, 3, and 4. So sigma of 1 is 3. That means 1 goes to 3. Sigma of 2 is 1. So that means 2 gets sent to 1. Sigma of 3 is 4. So that means 3 gets sent to 4. And sigma of 4 is 2. So 4 gets sent to 2. So sigma is the function that sends 1 to 3, 2 to 1, 3 to 4, and 4 to 2. And that's what a permutation is. It's actually a 1-to-1 onto function. A 1-to-1 onto function. But here it's basically just rearranging the numbers 1 through 4. It's rearranging them. So here I have a message. Flee at once. Now notice those spaces. Those spaces we're going to turn into X's. Everywhere we have a space, like flee, space, at, space, once, we're going to put X's. Now, since we only have 4 elements in our domain, we're going to break these up into blocks of size 4. So I'm going to have a block of size 4 flee. I'm going to have a block of size 4 XATX. I'm going to have a block of size 4 once. So we have 12 characters, right? 12, which is a multiple of 4, right? 3 times 4. So you have 3 blocks of length 4. 3 blocks of length 4. Now, what if you didn't have 12 characters? What if you had only 11 characters? Let's say you had 11. Well, then you put an X on the end. You have to put an X on the end to get 12. Why 12? You always want a multiple of 4 when you're dealing with a permutation on 4 elements. Okay, so we got 4. We have blocks of size 4, right? 3 blocks of size 4. So now we're going to perform the transposition. So I want my code over here. So we got 1, 2, 3, 4 spaces for each of these. 1, 2, 3, 4, 1, 2, 3, 4 for each block. So we're going to have the code here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So the permutation tells us that sigma of 1 is 3. So 1 goes to the third space. So the F is going to go to the third space. And sigma of 2 is 1. So that means the second letter, L, goes to the first space. And then the third letter goes to the fourth space. So E goes to the fourth space. And the fourth letter, sigma of 4, equals 2. So the fourth letter goes to the second space. So E goes to the second space. Okay, continuing. Now with the second block, we're going to start over. Sigma of 1 is 3. So the first letter X goes to the third space. The second letter, A, goes to the first space. The third letter, T, goes to the fourth space. And the fourth letter, X, goes to the second space. I've used my permutation. Now, let's do our last block. Let's start the permutation over once again. The first letter goes to the third space, so that's an O in the third. The second letter, N, goes to the first space. The third letter, C, goes to the fourth space. And the fourth letter, E, goes to the second space. So your code is L, E, F, E, A, X, X, T, N, E, O, C. That's your code. Right, so it's not very difficult. So in the next video, we'll look at decoding something that has been encrypted.